All right, so let's just continue our study of hypothesis testing with the proportion. All right, statistician read that at least, all right, so that means at least 77% of the population opposes replacing dollar bills with dollar coins. See if the claim is valid. The statistician selected 80 people and found that 55 were opposed to replacing the bill. Okay, so this is our, no, that's our alternative. At alpha equals 0.01, test the claim that at least 75% are opposed to the change. All right, so let's go to stat, go over to test, and it's number 5. All right, and we have 0.77, x is 55, then we have 80, and it's greater than. All right, so yours should look like that. Push enter. And then we have these values. I'm going to write those down. Okay, so this does not tell us to do the p-value way, so I'm not going to. Okay, on this one I added the p-value way. Yeah, this fly. Oh, it's driving me nuts. All right, so we are at alpha is 0.1. It is to the right. Oh, I almost thought I had them. All right, 0.1 to the right. So let's go to that charity chart. Right, 0.1, so 2.33. All right, so my critical value is 2.33. To the right. All right, and so 2.33 positive, so that's like here. So I'll have that shaded. Okay, and we have z is negative 1.75, so that's here. All right, it's in the white. So when it's in the white, then we accept. We just have to the null. Okay, let's do the same problem, but let's do it with the p-value. So we have p-value is 0.96 and the alpha is 0.01. This is bigger, and so when that happens, you still accept. So we're going to accept the fact that it's 77% of the population that wants to replace the dollar bills with dollar coins, or that opposes it. All right, so this is the p-value again, but we've been doing it, okay? Claim that more than 25% of all lawyers advertise. A random sample of 200 lawyers showed that 63 use some form of advertising. Alpha is 0.05. Is there enough evidence? All right. Did you notice, or have you noticed, that when we are doing this one, the z-test to the proportion, we're not putting mu here. We're putting p. Okay, I just wanted to point out that. Okay, so I'm going to stick this in my calculator. It says use p-value method. I'm going to go to stats and then test, or I'm going to go to this number 5, the proportion. All right, 0.25, x is 63, n is 200, and then it is greater than. So I'm going to push enter. I'm going to write that information down. All right, I got z equals 2.12. P equals 0.017. All right. And so we want to use the p-value method, and the p-value method is you compare the p and the alpha. So p we get 0.017, alpha was 0.05. This guy is smaller, and so when it's smaller, you reject the hoe. Reject a hoe. Okay, you reject the null. So that means that it is greater than 25% advertised. All right, let's do the same exact problem, but what if we did alpha at 0.1? And so this guy would mean I'm 95% confident that more than 25% lawyers advertised. Over here, let's do that one. So then P and alpha. Oh, just kidding. Let's do 0.01. All right, P is 0.017, alpha is 0.01, and so this guy is bigger. And so this one we would accept the null. And so he means I'm 99% confident that less than or equal to 25% of the lawyers advertised. This one means I'm 95% confident that more than 25% of the lawyers advertised. All right, and so that's how your confidence level affects it. All right, so you've learned the three main ways to do hypothesis testing. We do them in the calculator under stat, and then you go to test and you do either the z-test, the t-test, or what is the one dash proportions test. Right, and it calculates it for you, and then the most important part is really the analysis. All right, I'll talk to you later. Bye.